Hello everyone, welcome to our channel Code with Sunny, and today in this video I am going to talk about the problem triangle of LeetCode. Index number is 120 and the problem is of medium type of LeetCode. Okay, so basically this problem is one of the good problems of, or you can see the one of the good problems of the topic related to dynamic programming, and this problem is also the most frequent problem being asked in interviews. Okay, so let's discuss this problem now and we will together find out the best solution of this problem. Given a triangle array and we have to return the minimum path sum from top to bottom. Okay, so basically we have been given a triangle type orientation of an array and we have to return what would be the minimum cost for going from top to the bottom of this triangle. Okay, for each step we have the following moves. Either we can move to an adjacent number of the row below, that is, if you are an index at I on the current row, you may move either to the index I or index to the I plus 1 to the next row. Okay, so let's understand this with the help of diagram. That is, let's say you are at index, or you can say with a number at 2, you can either move to this 3 or you can either move to this 4. Okay, okay, so in spite of that, you can, let's say you are at number at this 5, you can either move to this 1 or you are going to either move to this 8. Okay, or let's say you are at this position, that is the value at 6, you are either going to this 4 or you are either going to this 1. Okay, so these are the basically moves that you are going to do. That is, either move directly to the current row, either move directly to the current column into the next row, or move to the next column of the next row. Okay, now what will the minimum path from top to bottom, that is from going from this to this end of this, you can say the end of this row, that is the last row. Okay, and we have to find out that minimum cost. Okay, so let's look over the constraints, because sometimes constraints might be helpful in figuring it out what is the best solution of this problem. That is, triangle length is going to vary up to 200, so we can have an O of n square solution and the values lies up to 10 power 4. And there's a follow-up: could you do this using only O of an extra space, where n is the total number of rows in this triangle? Okay, so let's find it out what will be the best solution of this problem and analyze this problem with the help of examples and diagrams. Okay, so let's move further. Okay, so basically we have been given this triangle, but we can convert this triangle to this you can say n into n matrix. How we are going to do that? Okay, so basically you can see for this 2 I have placed this at position 0 comma 0, and for this 3 4 I have placed next to this 2 such that it would lie as a number of columns should be greater than the number of previous columns plus 1. Okay, so you can see it will have 2 columns, and similarly for the next one it will have 3 columns. So starting from, you can see I have placed the elements like 6 5 7 from the leftmost side, that is 6 then 5 then 7, and it would become a n into n matrix. Okay, now converting this to an n into n matrix is just simply like you are just figuring it out what should be the best solution by just modifying this statement, because if you are representing this triangle with the help of this matrix, it would become easier to understand and interpret the solution of this problem. Okay, so what would be the, okay, so let's find out what are the possible moves after converting this triangle to this, you can say this n into n matrix. Okay, so you can see from this 2 you are going to either to 3 or to the 4. So you can see you can move to this either directly to the same column or to the next column. Okay, from this current row to the next row. Okay, so if this is done, so let's figure it out from what are the moves possible from 3 and 4. You can also see from 3 either we are going to 6 or either you are going to the next column of this next row. Okay, so if you are at 4, either you are going to the same, you can say the column, the row just next to this one, and with the and on the same column. And if from 4 you can also go to the next column of the next row. Okay, so overall if you are at I and J, let me write it down. You can either move to, either you are going to move from I plus 1, that is to the next row and the column remains same, or you are going either move to I plus 1 comma J plus 1. Okay, so one of the solution of this problem, that is either you are first going to convert this to a matrix, or just understand this that I am just interpreting a matrix, that is a 2D matrix of size n into n. Okay, and just finding out the solutions. Okay, so I think I have here done some mistake, it should be like 3. Okay, so now what we are going to do is just we are going to just modify my current, you can say there is a triangle. Okay, so there is a triangle given like that. Okay, can say vector of vector identity triangle. It is just a 2D representation of this triangle. Okay, so I'm just going to modify my this triangle 2D representation. How I'm going to modify that? Let's understand that. Okay, so it is just basically a dynamic programming approach. It's called the DP. Now you can see if we are at the second row, that is this is the first row, and we have this second row, and let's say we are at this element, that is element 3. So for this element 3, we can either come from okay. So how we can come to this element 3? Okay, so for coming at this element 3, we can either come to this element 3 directly from this one, that is for the row just above to this row, or let's say if we are at this 3, then we can either come to this that is for the row just above this row, but the column is just less than 1. You can see this is out of the bounds of this matrix. This is not possible. Okay, so it means that we are at this 3, then we can always come from this above 2, that is to the row minus 1, and the column remains same, that is j remains same. Okay, if I'm just talking about this 3, and what about, say, let's say we are at this 5. Okay, so how can we come to this 5? We can come to this 5 by coming from the row just above this row, that is to the I minus 1, and the column remains same. Okay, and now there is one more chance that we can come to this 5, and what is this chance? That is from 3. Okay, so for I and j in general, I can write, we can come from I to j from I minus 1 always. Columns that is number of row number should be always less than 1 to this current row, and we can always come from this I minus 1 to j, or we can always come from I minus 1 from I minus 1 comma j minus 1. Okay, if this j minus 1 is going to be valid, okay, for this triangle. Okay, so just I'm going to modify my this triangle 2D representation that is given to us starting from I equal to 1. If I have 0 based indexing, that is this is 0 and this is 1, this is 2, starting from I to 1, and it goes up to I less than n, where n is the number of rows of this triangle. Okay, so for every I comma j, and where j is always going to be like j should be less than equal to I. Okay, so for every I comma j, I am just going to check it out if what should be the minimum cost coming from either from this position or from this position. Okay, so let me write down the DP relation, that is dynamic programming relation, for this 2D representation of this matrix. Okay, so let me write it down. Okay, so let me just write down DP of ij, or you can also write it as let me write it, let's say I have this triangle that is given to us, that is I have just mentioned this vector of vector identity triangle that is given to us. I am going to just modify this triangle. Okay, so how we are going to do that? Let's say this is named as t. Okay, so I have this t of ij, T of ij should be equal to, that is plus equal to my current value, that is if I want from what are the total distinct values, that is total different ways I can come to this 5. Either we can come from the row minus 1 and the column remains same, that is from this, or you can also come from this row minus 1 comma column minus 1, that is from 3 to 5. Okay, so I can come from like a minimum of, since I need to find the minimum cost for reaching to the bottom of the cell at each time, I need to take the minimum cost obviously. Okay, so I can come from minimum of this t of I minus 1, always number, always row minus 1, because I'm always just trying to come from this previous row, and my j either remains same, that is to the from the same column of the previous row, or I can come from t of I minus 1 or to the previous column, that is j minus 1. Okay, and if I take the minimum of these two values, I must need to add to my current value, that is 5. What is the minimum cost for reaching to my current cell? Okay, so if this is done for the entire cells of this triangle, what should be our answer? Our answer should be like minimum of all the costs that we can have up to reaching all the cells of this last row. Okay, because since you focus on this the question, minimum path sum from top to bottom. Okay, from top to bottom, it has not been specified that bottom, if we are reaching at the bottom of this triangle, at which cell we are going to end. We can end at any cell, that is either we are going to end at this cell, at cell with value 4, or cell with value 1, or cell with value 8, or cell with value 3. but we don't know which will give us the minimum cost, whether we are ending at this current cell. Okay, so I need to take the minimum of all the values of dp of, let's say dp, or you can also say the t of n minus 1 is the last row, and t of I for all the values of I ranging from this 0 to n minus 1 for all the columns. Okay, that is 4 1 8 3. This should be our answer. Okay, now you can also see there is a one follow up that we can use this in O of an extra space. Okay, one thing that should be kept in our mind, that in interview related questions we must not change the actual input data. That is what I have done over here is that I have modified this triangle vector, or you can say 2D representation of this triangle, and I've just modified this vector to just find out my answer without using an extra space. But in interview related questions we are not allowed to modify the input values. So we must either to solve this problem we must make either the 2D matrix for figuring it out the answers, or we can, in this case, like in this 2D matrix, so what will be the my space complexity, extra space, it will be like O of n square, and this is going to be worst. Okay, so we must try to figure it out, like how we are going to minimize the space complexity, that is extra space. So I am going to just tell you how we are going to minimize this extra space without modifying my input values, that is in a triangle 2D representation of the vector. And what is the minimum extra space complexity, that is I'm going to just tell you O of n extra space, and is basically the number of rows, which is actually the follow up that have been given to us at the beginning of this problem. Okay, so you can see, could you do solve in O of n extra space? Yes, I can solve. Okay, let's try to figure it out. What would be the O of n extra space solution? How we are going to modify my entire problem statement and entire problem scenario of this problem to figure it out, the O of an extra space solution. Okay, so let's move further to find it out. Okay, so here is one the DP relation that I have written over here. So if you focus on this DP relation, that is, it only needs the values for answering for a particular row. You just need the values for the answers for the previous rows. Okay, that is if you need to answer for this row, that is for the cell with 3 and 4, I just need the answer for this previous row. Okay, so rather than maintaining an entire 2D matrix for without modifying my actual values, we just need to have a linear size array, that is answer of, let's say answer is the array, and what is the maximum number of rows, or you can say maximum number of columns that we can have. It should, let's say it is n, that is, here you can see here it will be 4, that is answer of 4 that I need to maintain. Okay, so let's try to just answer the you can say fill the row and columns. Okay, for the cells. Okay, that is, you can see here I will have maximum of 4. Okay, so if you are at this cell with value 2, what is the minimum cost for coming to this topmost, to this my current cell, that is from 2 to 2, it should be like only 2. Okay, and let's try to just answer for the some more cells, like okay, so just let me fill it down like 2. Okay, let's try to answer for this 3. What is the minimum cost for coming to this 3? So you can always come from this 2 to this 3, and what is that cost? You can say 2 plus 3, it is going to be like 5. Okay, so let me just erase this stuff and let me just write it down, the value equal to 5. Okay, and what is the minimum cost for this coming to this 4? You can always come from 2 to this 4. Okay, and what is that cost? You can easily see the cost would be like 2 plus 4 6. Okay, one thing that should be noted here, that for answering these two queries, what is my previous answer vector, that is still not modified. You can see it is still only 2, and for answering this 4 I just need this value 4. Okay, now what is my new answer vector that is present over now? You can easily see my new answer vector is nothing but, you can say new answer vector is going to be modified, and it is nothing but 5 and 6. Let me fill out the values. You can say this is 5 and this is 6, and let's try to answer for this row. If we are trying to answer for this row, let's try to answer for this cell with value 6. You can always come from cell with value 6 to this cell value, that is from this 3. Okay, so you can say what is the minimum cost for coming to this rate is 5, and 5 plus 6 is 11. Okay, so the minimum cost is 11. And what is the minimum cost for coming for this cell here? If we will have 5, I think I've just messed it out. And what is the minimum cost for coming to this 5? Minimum cost for coming to this 5, either either you are going to go from 3 to this 5, or you are going to go from this 4 to this 5. Okay, so minimum would be like minimum of this three cell with values 3 and 4, that is minimum of this 5 and 6, and minimum of 5 and 6 is nothing but 5, and cost of this current cell is 5, it should be like 10. Okay, and what is the minimum cost for coming to this 7 cell? You can always come to, from this 4 to this 7. Okay, and what is the minimum cost for coming to this 4? It is nothing but 6, and 6 plus my current cell value, it is nothing but 13. Okay, so my new answer vector is this one, and you can easily see I just need the values for the previous row, that is only 5 and 6. Okay, so this gives me the idea to just, rather than maintaining an entire 2D matrix, we just need a exactly linear row. Let's try to fill up the values with the help of previous row that we have. Okay, so let's move further to the coding part to analyze how this can be implemented in the best way. Okay, so let's move further. Okay, so I have already submitted the codes. Let me look over the code, and let us try to just figure it out what I have done, and let me explain over that. Okay, so let me open up the two accepted code. That is one, that is I've just modified with the input values, which is not actually valid interview related questions. Okay, so you can see I have this triangle vector, the triangle representation of 2D matrix, and you can see n is going to represent the maximum number of rows that this triangle representation can have, and starting with I equal to 1, and it goes up to less than n, because of first row it is not required to just modify the first row, because it is actually the beginning one. Okay, and it holds only one value, that is, you can see it holds only value equal to 2. Okay, and let's try to just fill up the values. What is my current minimum? Let's say anti max, and what is the minimum? I'm just trying to fill out what is the minimum value for coming to this cell, rather than just adding the values. Okay, finally you can see I have just added the value of triangle of ij plus equal to the minimum, that is minimum cost from which we can come to this cell, and minimum would be like minimum of this my previous row, and the column remains same, and minimum of this previous row and column minus 1, that is j minus 1. If and only if j is going to be valid, you can see if j is going to be less than I minus 1, and j minus 1 must be going to be greater than or equal to 0, because you can see this triangle has the orientation, like you can easily see every time the number of columns is going to be increased by 1. Okay, so I just need to take care of that. Okay, so if j is going to be less than I minus 1, and j minus 1 should be greater than or equal to 0. Okay, so when j is going to be less than minus 1, its condition is going to fail. The condition will fail only when we are at this position, you can this 7 and this 3. Okay, so because if you are trying to fetch the exactly previous row, it is not going to be valid. Okay, and j minus 1 is greater than equal to, this will condition will fail for the just first column. Okay, so finally, and what should be our answer? Minimum of for all the values for the last row. Okay, for any of the columns can be gives us the answer for this last row. Okay, so just I need to find the minimum value, just I have returned the minimum value for the last row and for any of the columns. Okay, so this will have a runtime bits of 90.75 of CPP submissions. Okay, so let's talk about my another implementation, that is nothing but maintaining a vector of size and without modifying my input values, because in interviews you cannot just modify the interview value, and this is going to be invalid. Okay, so I'm just maintaining, rather than maintaining an entire 2D matrix, I just maintain a, you can say, answer vector of size n linear array, and this answer of 0 is nothing but triangle of 0 comma 0, which is the first value or first cell value of the first row. Okay, so just I have iterated for I equal to 1 and it goes up to I less than n, or I am just trying to fill up the values from the back side. Okay, so because if you try to fill up the values from the back side, you can easily see for filling the values up to for this cell, I just need the values for this previous one, that is answer of I minus 1. Okay, so if I have just modified this, that is, if I just filled up this values of this cell, I just don't need this cell anymore. Okay, so if you try to fill up the values from the beginning of this cell, you can see the values are getting modified. Okay, so if you are trying to fill up this value, just I need the values of this one and this one. Okay, so if just I have just filled this value, this cell value is going to be modified. Okay, that's why I'm trying to fill up the values from the back side. Okay, so without getting an error. Okay, so just j from I and j greater than equal to 0 and j minus 1. If j is going to be equal to I, my answer would be like j minus 1 plus the current cell value. And if j is going to be exactly 0, the only way that I can come from is answer of 0 plus triangle of ij, my current cell value. Otherwise, we can have the two possible ways, minimum of answer of j and answer of j minus 1, plus triangle of ij, and we have to return the minimum element, and finally after traversing all the rows we'll have the values for the last row. Okay, that is minimum element of this one. Okay, I just returned this. This will also have an accepted code. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.